everybody. Welcome to lesson 2-4 on graphing inequalities and absolute value. I'm going to just show you two problems today. They shouldn't take too long. Some of it's going to deal with some partial knowledge you'll need from previous math classes and previous lessons. So for example 1, I'm going to be graphing inequalities. Now an inequality is basically less thans or greater thans and stuff like that. So looking right there, that's a less than symbol, so that's how you know that this is going to be an inequality as opposed to an equal sign. Now if this was an equal sign, I'd be graphing a line. But since it's a less than or greater than, less than or equal to, or greater than or equal to, it's going to be a shaded region. So for this problem here, my favorite way to graph is to get equations into slope-intercept form, which I have listed below here. Hopefully you remember that, y equals mx plus b. The m is the slope, and you're going to use rise over run in the slope idea. And the b is where the graph crosses the y-axis. It's called the y-intercept, abbreviating that, int for intercept. But the slope number and the b, the y-intercept, are just two numbers you need, and then you're done, basically. So from unit 1, you should know how to get y alone. It's getting rid of this 3x by subtracting 3x. Now, why do I want to do that? Because if it's not in y equals form, as you can see down here, it's harder to graph. So I subtract 3x from this side also. 3x and 4 are not like terms, so I'm going to leave it as y equals, but in this case it's less than or equal to. And I like the x first because in this formula, the x is listed first. Negative 3x plus 4. Now that's a line with a shaded side. So let me do the line first. Where do I start? I start with the y-intercept. B is sometimes thought of where to begin. So I'm going to begin at 4 units up on the y-axis. This is the y-axis right there. So 1, 2, 3, 4. I'm going to start right here. And then I'm going to use my slope, 3. And if it's a whole number, you got to think of it over 1. If it's a fraction, it's easy. But 3 over 1 is my rise over run. So slope is rise over run. So 3 is negative, however. So from this point, I am not going to go up 3. I'm going to go down 3. 1, 2, 3, and I'm going to run 1 unit. So this is a movement. Rise, or in this case falling, and then running is always to the right. Now I'm going to use a line here, and I'm going to connect these dots. I'm going to do this the best I can. It's kind of tricky in the smart board, but I think that was pretty good. And then you could put arrows on. You should put arrows on the ends of these because that line does go on forever. However, this is not a line. It's a shaded spot, so it's one of these sides. I'm going to tell you 2 tricks on how to know which side to shade. Trick number 1: if the y is alone and it's less than, it's underneath. That's just a fact. Okay? If it's greater than, it's above. You only do underneath or above. Now, there's another way to do it, and that's to do a test point. You might have done that in your previous classes. I like to do test point 0, 0 unless the line goes through 0, 0. And I go back to the original problem, and I see if 0, 0, which is right here, is true or false. 0 in for x, 3 times 0 is 0. 0 in for y, plus 0. And I just see true or false. Is 0 plus 0, which is 0, less than or equal to 4? The answer to that is true. So I shade the 0, 0 side. Having the use, let's try a crayon here first. It's a little bit different. That's kind of pretty. So I'm going to be shading this side of the line. So everything over here is what I'm shading. So remember, this line goes on forever, so this is all of it. Now, if you're using a pencil, you can just kind of use the edge of the pencil, or you can just draw, shade as best you can. What this means is all of the points on this side of this black line are true solutions here. Now, how do you do this one? This one's weird. Well, hopefully, let me change colors here. Let's do green. Hopefully you understand that x equals 2 is a vertical line. 1, 2. If you don't know that, you have to have that memorized. This line here has all x values of 2. 2, 0, 2, 1, 2, 2, 2, 3, 2, negative 1. That's why it's x equals 2. However, it's greater than. So you shade one side or the other a line. Now, if it's vertical, you can't decide underneath because there is no underneath because this goes on forever. So you have to shade right or left on this case. X is greater than 2 is shaded to the right here. So if I just had a pen and I was using the same color, I would just kind of squiggle it into the side of the line. Now there's a little tiny thing you have to understand when there's not a bar underneath here. It's not equal to. So that means it's not a solid line like this one was. So it's really a dotted line. So I'm going to actually just erase. Oh, God, that's too big. I want to make that smaller, a really tiny eraser. So this line here is dotted. Okay? And that's the things you need to know on graphing inequalities. Now, there's a lot of practice you're going to need in class for this, but this is just the surface on how you do it. Graph the line, shade one side or the other, and making sure the line is shaded or solid or dotted, and do the other. And the last thing you have to understand here is that there's an overlapping shade on a couple of these. So the overlapping shade I'm going to darken in. So this black line keeps going. And this green line, oh, I lost my green here. There it is. The green line keeps going, but it's dotted. Can you see where they're both shaded? So this is over to the side, and back to my crayon. This one's underneath. Can you see that this little wedge right here is where they're both shaded? So you're going to either darken those in or you're going to use like a highlighter or something. And this is the place where both of them are true. So that's why we have the word and here. You have to double shade the overlapping section. All right, so that's how you graph inequalities. Absolute value. Absolute value, hopefully you may remember, are V's. So the graphs look like this. I'm going to show you two of my favorite ways to do this. Way number one is looking at this general equation and knowing that the V gets moved by the H. I'm going to put this over here with the green, left or right. If you have a minus sign here, most people think it should be left because it's a minus sign, but it actually goes right. Oops. So if you see a minus sign, you're moving it right. And if you see a plus sign, you'd think it would be moved to the right, to the left. It actually gets moved to the right. So left is plus, right is negative. Now let me change colors. Let me go to purple. What about the K? The K is a movement up, or down, but this is not backwards the way you think it goes. So this is a memorization device. So K, if the K is positive, you think it would go up, it does. If the K is negative, you think it would go down, and it does. So I don't have enough room here, but I'd probably write these kind of together here. That's the K information. And then this is the H information. What does the A do? The A is just the slope. So it's how slanted your V is. Okay, so let me just show you one. So this is a V. The normal V starts at 0, 0 and looks like this. Boom. Boom. Okay? But now I'm going to move the corner. That's all I have to do is move the corner. I'm going to move it 3. That's the H number. It throws 3. Which way does 3 go? Because it's minus. Minus is right. So I'm going to move it right 1, 2, 3. And then I'm going to move it 1 unit plus, 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 up. 1 unit up. So right here is my corner, my V. How slanty do I make it? Because the A doesn't appear here, it's a 1. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, back 1, up 1, back 1. So here are my two V areas. And then I just draw and connect them. And I go bloop. And I go bloop. That's all you have to do. Now that's one of my favorite ways to graph an absolute value. I'm going to show you my second favorite way real quick, and that's just by doing a table. You can always do a table if you don't know how to graph things. The only thing you have to know is that this is a magic number. It's the corner. And you have to flip the sign. So I'm going to put 3 here. So if I put a 3 in for x, why did I pick the 3? Because there's a 3 here. If there's a 5, I'd put a 5 there. If it was plus 5, I put the sign and put a negative 5 there. So I put a 3 there. That's my x value. Plug it in. What's 3 minus 3? 0. The absolute value of 0 is 0 plus 1. You just do a little math. 3, 1. Hey, guess what? 1, 2, 3, 1. That's the corner. Pick a number smaller, 2. Pick a number bigger, 4. Pick easy numbers. They'll help you. Let's do the 2. Plug in a 2. Let me do this in purple. Plug in a 2. 2 minus 3, negative 1. Absolute value of negative 1, 1. 1 plus 1. Don't forget to add that other 1. If there was a 4 out here, you'd have to multiply 2. 1 plus 1 is 2. 2, 2, 2. 1, 2, 1, 2. Hey, that's that point right there. And you do it again with the 4. 4 minus 1 is 3. I'm sorry, 4 minus 3 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. You graph 4, 2. Then you have your 3 dots, and you draw your line like I did. So that's basically how it goes. You have the choice of memorizing this little, we call this parent function, and being able to move it and translate it. Or you can use this whole method right here of plugging in points and just knowing where you have to start. That start is called the vertex. That's it for this lesson. Good luck. It's a little bit challenging. I know graphing sometimes is. Thanks for listening.